What's going on, guys? It's Cal here from KR Sabers. So this is going to be a nice simple tutorial today, just to go through how to make a NeoPixel blade with the new KR pixel sticks that are going to be coming out. Pixel stick, I guess, is just a temporary name for the time being. I can't really think of a cool name to call it yet, but I thought I would go through and show the parabolic tips that are going to be coming out on the Saber Armory. And also we're going to be stocking polycarbonate tubes. So usually when I make blades, I use a few different tools, but I've tried to use the least amount of tools here as possible, because, for example, when I cut my blades and I trim them down, I do it on my lathe, but not everyone has a lathe, so I have to show you guys how that would work if you just had hand tools. So this tool here is just it's a saw guide basically, and you can put your tube in here, you can clamp down your tube and hold it in a vise. This extra bit is to hold it in a vise, and it gives you a guide, so you can use something like a small like hobby saw or hacksaw, and you can cut your tube. Then we've got a pair of scissors for cutting foam. We might not need the fusion film, but sometimes it's good to add. It's also important to add your Loctite to glue your tips on, or if you want to glue your holders in. They should be quite push fit anyway on there, but just in case you want some glue. You'll need a PCB, blade side PCB. I'm just using my KR Pixel PCBs. They've got a high copper weight for the amount of current that goes through them. In my testing and from tests I've seen of other people who use the KR ones, they get a bit of an improved brightness. So I think Britain of Saber Royale done a test, and it was quite useful to see the difference in how the copper weight of blade PCBs affects blade brightness. So I'm going to be using one of these. This is one of the holders for them for thick wall blades. And I guess the first step really is to decide which blade style you want to use. So right now I'm using the thick walled, because the thick wall foam that is currently available on my store, and I also sell it to TCSS, fits nice and snug to the LED strips. However, the thin walled foams, there's a little bit of a play, and it causes a rattle, which is why there's been a bit of a delay in the release of these strips. Because if you want to make a thin wall blade, the current foam that's available on my store and on TCSS, it causes the PCB to move around a little bit. Basically, the PCB is 10 millimeters wide. Now the inner diameter of these thick walled tubes, or for 7/8 inch blades, is 10 mil, so it's nice and snug. However, the ones for thin walled blades are 12 mil, which is why the PCB moves around a little bit. So for this tutorial, I'm going to be making a thick walled blade, just so you guys can sort of understand how the strip works. So we've got this strip here. This is one of them. They come in this nice ESD safe packaging, bubble wrap. So we've got that there. And as you can see, if I zoom in a little bit, in total we've got 263 LEDs on there. They're the highest quality LEDs. Well, is that 264 LEDs on here. So the highest quality chips that I've tested and done testing with Dimitri. You can see the edge is nice and curved on there, so that is easy to slide in the blades. It's already double-sided but staggered, as you can see, so you get nice diffusion. And you've also got nice big solder pads to solder to, with the data line already being resisted. So you can solder either side. You only need to solder one side really to make soldering nice and quick. And what I often do is I keep these little I keep these wires from LED strips that I've used in the past, because they're good gauge wires, and instead of sort of wasting them, I'll keep them, and I'll use these for soldering to the PCB. So if I just cut off a little snip there, I'll use this, and I can sort of easily it's got voltage data. Let's have a look. Voltage data and ground. It's just quite easy wires to use. And on the KR PCB, obviously there's no SMD footprint, but we just need to tin the data, negative and a positive, and 3 wires. That's it. The blade is actually very quick to make. It's not a long process. It's very quick, very easy, and I think you guys should really see that. So I'm going to take the blade out of the plastic. But essentially I'm going to put the tip on the end of the LED strip. I'm going to hold it on the lip here, so I know where it's going to be. And if I keep pushing, so I want to get my marker pen, and I want to leave some room for wires and the holder itself. So I just get the holder here, put it there, and I'm going to cut, probably I'll cut here, just leave myself a bit of room. I'll cut there, and that should be, yeah, that should do it. So I'll draw a line there nicely. And what I want to do now is I'm going to get my little saw guide. I'm going to look down here to see the mark. So let's back this out. So get the saw guide. We'll wait till we see the line that we made. So that's not really, this should be held in a vise, but I'm trying to do it whilst on camera. We'll just get our hacksaw. We'll just make a light cut at first. So this allows you guys to not have to worry about having any electric tools or anything. You can just have a hacksaw and a little saw guide like this, nice and easy. Got a nice clean cut. Take this off now. That's all we need for that. And we can use something sharp like a Stanley knife just to get rid of any burrs that are inside. The little one there. We can blow down the tube as well just to get rid of any dust. And even if you've got a can of compressed air, you can use some compressed air to get rid of it. So now you can see that fits in there nicely. So I've just got some 320 grit, and I'm just gonna lightly get those edges. And it's looking much better already. And there we have, we've got a nice clean edge and no use of any power tools or pipe cutters, because the pipe cutters will create a beveled edge and it will cause a problem for the holders going in. So you can see now the holder goes in there nice and push fit. It probably doesn't even need any glue, to be honest. We'll just check again for any dust. So I just use some of that compressed air to get any dust out of there. It's all nice. So we can glue the tip on now. So I'll get a bit of super glue and I'll just put a few dabs there. I'll just rub it across. Put that on. Spin it around a bit. Make sure it's on there nicely. And if there's any excess, just use a bit of tissue. I'll just wipe that away. So we want that to dry completely before we start putting anything in it, because we don't want it to pop off. So I just sanded the outside of my blade to get a bit of extra diffusion and to blend the tip in, because I like to sand it so that there's no glue residue and give it like an overall frosted look. Now you can see when we put the foam in, we want to make sure we get the right length. So the foam's going to go to there. We want to take off about an extra little bit for the blade PCB holder. So we want to cut just a little bit. So what I'll do is I'll cut the excess off first, like that. And really, well, it should still go in. Yeah, I mean, we don't need to do any more than that. So the foam's in there now. Now I'm not going to put any blade film in yet, because I think it might be okay, to be honest. So we've cut our tube without using any power tools. We've glued the tip on. We've sanded the outside just to give it a nice even look, frosted sort of look. We've put the holder in. We've cut the foam to size. Now you can start by putting the PCB in. We'll just keep going. It'll go all the way inside. But what we're going to do, we're going to leave this out a little bit, because we're going to jump over to the soldering iron and solder this on. So that's all we have to do now, guys. We have to solder these wires on, and then we're good to go. So right now we're at the soldering disc, and I'm just going to get my pads of the PCB nicely warmed up. So I'll get a bit of flux here. I'll put them on the pads. Let's take a look. Get a bit of flux. Because you want to put a bit of flux in. They're quite large pads. And we're just going to pre-tin them really. And we're just going to first one. Let's heat this up. So it's got a bit of an angle. That's 1, 2, and 3. Clean off some of this flux. There we go, 3 pads soldered, and then we're going to tin the pads on the back of the PCB. So I just need data, I need a positive, and I need a negative. There we go. We've got those 3 pads tinned now as well. All good, nice and clean now. Then we're going to prepare our wires. So we'll just tin these again for good measure. Let's take a look. And we can start connecting them now. So we've got positive there, nice and straightforward. Always put a bit of flux on them again anyway. Sorry, I always like to make sure my solder joints are nice and clean. That's all connected. So we've got our negative, data, and positive all connected now. So any sort of 22 gauge wires are good for NeoPixel. I'm just going to trim them and strip them. Sorry, strip them. 1, 2, 3. Now we're going to tin them. Bit of flux. 2, 3. And we're going to get connecting, so we've got positive, data, and the negative. Get it heated up, because we put a lot of solder on there. So that's the positive connected, data's connected, and the ground's connected. And then here, give it one last little brush. And that's that. The wires are connected, we can push the PCB in now. Just a little bit, we can use some tweezers to push it in a bit further, and then I'm just gonna click it in, and that's it. So just to make sure it's in there, it's in there nicely. And now the next stage is to test it. Okay, so the blade's finished. I've got a Saber here. My Verso flagship was out of battery, unfortunately, so we'll just slide it in. We've got the lights on in here as well. Make sure that's seated properly. Feels like it's in there nicely. Let's boot the Saber up. Let's turn it on. So, got yellow. This is white. So you can see how bright it is and nicely illuminated. Let's go yellow. Green, blue, and the diffusion's really nice on it. And that's got no film in it, it's just the foam and the LED strip. And the tip is nice and evenly illuminated. If I bring it a bit close to the camera, you can see it's lit all the way to the tip. With those hollow tips, the LED strip's gone right to the very end. This is white again. Usually when you hold them up close to the camera, the exposure usually adjusts, but you can see it's still nice and bright. I mean, we can see what it's like with the lights off. So very nice and bright. This is white, yellow, red, and usually red is the telltale one on cameras. But you can see the tip of the Saber's nice and bright, really bright, and nicely illuminated, and just easy to make. That's the main thing about these strips. You want them to be easy to make. It's got royal blue. Again, royal blue is one that usually washes out on camera, but you can see here it's nice and even. So guys, hopefully this makes your lives a bit easier when it comes to assembling blades, and you guys can now start building your own blades. So with that being said, cheers guys.